Hello guys, welcome back to my YouTube channel. So our topic for today is probability distribution. When we say probability distribution, it is a record of all the probabilities. Okay, so let me discuss the steps on constructing a probability distribution. First, we're going to determine the sample space and assign letters that will represent each outcome. Second, we're going to count the number of the value of the random variable, wherein the capital letter must be assigned. Third, given the total possible values of the random variable, assign probability values to each value of the random variable. So we're going to apply the following steps on the examples. Okay. But first, let me discuss what is a probability. Okay, probability, also known as P of X, is also defined as P of X, wherein the favored outcomes is the numerator, while the total number of outcomes is the denominator. So the probability can be represented as either a decimal or a fraction or a percent. So either the three of them, it's okay. Okay, so let me discuss the first example. Alanis had chosen her three of her classmates as her research group mates. Let M represent the random variable representing the males Alanis had chosen. Okay, so first, we're going to construct a table consisting of possible outcomes along with the values of the random variable. Then, we're going to construct a probability distribution table. Okay, so here, what did I do is I had constructed a table consisting of possible outcomes. So the possible outcomes represent a sample space. Let me name each of the outcome. Okay, so this is our first outcome, MMM. Then this is our second outcome, MMF. This is our third outcome, MFM. While the fourth outcome is FMM. While the fifth is FFM. While the sixth is FMF. While the seventh is MFF. And the last is FFF. So each of the outcomes represent all capital letters. Okay, so now we're going to find the value of the random variable. M. So it's not A, it's really M. Okay, so what are we going to do here is, so this is M instead of A. So this is M. So the value of the random variable is, okay, so for MMM, it will be 3. Why 3? Because there are 3 males. Okay, how about for the next 3 outcomes? Why 2? It's all because we have 2 males given. Okay. How about the next 3 outcomes? The FFM, FMF, MFF. It will be 1, 1, 1. Why 1? Because we only have 1 male in these outcomes. While in FFF, we have no males. That's why it's 0. So now we're going to count the values of the random variable. Okay, so, okay, since we have only one tree, it will just be 1. While for the 2, it will be 3. For 1, it will be 3. And for 0, it will be 1. So how many total possible outcomes do we have? So it is 8. So now we're going to state the probability for each outcome. So for 1, here, it will be 3 over 8. For 2, it will be 3 over 8. For 3, it will be 1 over 8. Then for 0, it will be 1 over 8. Why? It's because why is it 1 over 8? Because there is only one outcome which consists of all males, while here we have 3 outcomes wherein there are 2 males. Then we have also 3 outcomes wherein there's only one male, and here for 1 over 8 there's only FFF consisting of no males. So it means to say there is only one outcome where there are no males. Okay, so now we're going to proceed to the next slide. So as we see, so here are the number of males. So basing on the value of the random variable. So here's a probability. So recalling, for 1 over 8 it will become MMM, MFM, then MMF, then FMM. For 3 over 8 it will be FFM, FMF, MFF. For 1 over 8, it will become FFF. Okay, so this 8 is the number of total possible outcomes, while the numerators are the number of favored outcomes. So also known as the frequency of the number of the random variables, or shall I say value. Okay, so now we're going to move to the next slide. So by the way, this is the frequency distribution based on the problem I had really discussed. Okay, so we're going to the next example. Maxine had a basket of apples and oranges. She gave 4 of the fruits to her son Melvin so he could have snacks in school. Let A represent the random variable representing the apples Maxine gave. We're going to construct a table consisting of possible outcomes along with the values of the random variable. Then we're going to construct a probability distribution table. Okay, so we're going to do the same step. Okay, so now we're going to list all the possible outcomes. So our first possible outcome will consist of all apples. Then now we're going to list all the possible outcomes wherein we have 3 apples, while we're going to list the all the outcomes wherein we have 2 apples. Then we're going to list all the possible outcomes wherein we have only 1 apple. And last but not the least, we need to state the outcome wherein we have no apples. So we have to state all the possibilities. Tada! Okay, so here is the list of total possible outcomes. So now we're going to count all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we all have 16 total possible outcomes. So now we're going to determine the value of the random variable A. So A represents the apple. Okay, so now we have 4, right? Why 4? Because we have 4 apples chosen. While for the outcomes having 3 apples, so we have 3 apples, right? From AAAO, AAOA, AOAA, OAAA, AAOO. From AAOO until OAOA, we have 2 apples, right? So keep in mind that we have 3 apples from AAOA, AOAA, OAAA. That's it. While from the 2 apples we had chosen, OAAOO, AOOA, OOAA, OAAO, AOAO, OAOA. Then, for the outcomes where we have only 1 apple, OOOA, OAOO, OOAO, AOOO. For the outcomes wherein we have no apples, 4 O's, then it's 0. So now we're going to count how many 4's we have. So it's 1, That's why the probability is 1 over 16. While here, we have 4. So that's why it's 4 over 16, rounding off to 1 over 4. Then here, we're going to count 1, 2, 3, 4, 5, 6. So it's 6 over 16, rounded off to 3 over 8. Then for ones, it will become 4 over 16. Then it will become 1 over 4. Then for 0, it will become 1 over 16. So let me discuss it again to make all things clear. Why is it 1 over 16 for 4? Because there is an only outcome wherein we have only 4 apples. While here, why is it 4 over 16? Because we have only 4 outcomes consisting of 3 apples. While here, why do we have 6? Why is it 6? Because we have only 6 outcomes consisting of 2 apples. While here, we have 4 outcomes consisting of 1 apple. While here, we have only 1 outcome consisting of no apples. So here's how we find the probability. So we have to count the frequency of the value to get the desired outcomes. Okay? While the total outcomes is always the denominator, the total number of outcomes. So now we're going to proceed to the next slide. Okay, so here's how we construct a frequency distribution. So the number of apples represents the value of the random variable. Well, from the probability, as I mentioned here, so we stick it here. Okay, so let me write here. So this is A, O. Here, A, O, A, O, A, then A. From 6, A, O, then A, O, A. Then here, triple then triple O, then and so on and so forth. So that's how we list all the outcomes. That's how we recall. So we have only one here, then 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, then 1. Okay, that's how we construct the frequency distribution. We record the values of the random variable along with the probability. Okay, so here's our trivia. This is a trick wherein we're going to list all the favored outcomes. So we're going to add, for example, if Desiree had chosen 3 children, okay, so the total number of outcomes is we're going to add 1 plus 3 equals 4 plus 3 equals 7 plus 1 equals 8. So 1 plus 3 plus 3 plus 1 equals 8. So that is the total number of outcomes. While here, 1 plus 4 plus 6 plus 4 plus 1. So it will become 16. While this is will be 32. This will be 64. This will be 128 and so on and so forth. Then this will be 4. So this 2 is the number of choosing samples, right? So I chose 2 apples, while here I chose 3 apples. Let's say I chose 4 apples, I chose 5 apples, I chose 6 apples. So we have to consider, let's say, red and green apple. Okay, so th- this is the number of all red. This is for all green. So this one is for, let's say, one red, one green. Okay, so here, this is the number of all the favored outcomes. Okay, so this will look like 1 over 4, 2 over 4 equals 1 half, then 1 over 4. While here, 1 over 8, 3 over 8, 3 over 8, then 1 over 8. Then 1 over 16, then 4 over 16, then 6 over 16, then 4 over 16, then 1 over 16, and so on and so forth. Okay, so keep in mind that this is the number, represents the number of, let's say, objects chosen. Then here, if we add this will be the total number of outcomes, where each number in each box, or let's say in each hexagon, will represent the desired outcomes. Then we're going to use each of them as the numerator, then the sum of this will be the denominator. So we can use this to as a guide to construct the frequency distribution. For example, I have chosen 7 children from the orphanage. Then I will use this row as a reference wherein I'm going to create a probability distribution. If I chose, let's say, 10 crayons. Okay, so I will use this reference. Okay, where each of the numbers will be used as the numerator. Then the sum of all numbers will be the denominator to find the probability for each value of the random variable. Okay, so this Pascal triangle can be used as a guide. You can use this as a guide wherein you're going to construct a probability distribution. Now, so we're going to discuss the properties of a probability distribution. Okay, the probability of each value of a random variable must be between 0 and 1 or equal to 0 and 1. So we can also write it as 0 is less than or equal to p of x is less than or equal to 1. The sum of the probability of all values of the random variable must be equal to 1, or the summation of p of x is equal to 1. If we all add all the probabilities, it will become 1 or 100%. So here's the example. So the daily number of phones being sold has a probability distribution table which is on the left. So find the following. So p of x which is greater than 4. Okay, so we have to consider values which are greater than 4. So the only value greater than 4 based on the table is 5. Okay, so it's P of 5. So to find the probability according to the number of phones sold, which is 5, okay, so we can correspond here to the we can correspond here. So therefore it's 0.13. So number 2, if P of x is which is equal to 2, we have to correspond here, which is 2. That's why your x is equal to 2. That's why it's p of 2. Then we have to correspond it, which is 0.34. Okay? Then how about p of 1, which is less than or equal to x, which is less than or equal to 3. So we need to consider values which are between 1 and 3. However, we have to consider 1 and 3 as well because x is equal to both numbers. Okay. So we have to consider P of 1 plus P of 2 and P of 3. Okay. Why P of 1 plus P of 2 plus P of 3? Because this x is equal to 1, while x can be equal to 2, while x can be equal to 3. So we have to find the values corresponding to each of the number. So 1 corresponds to 0.15, while 2 corresponds to 0.34, while 3 corresponds to 0.7. So, tada, then we have to find the sum of each, which is 0.56. Then we're going to find the values between 2 and 5. However, 2 and 5 are not included because x is not equal to 2 and x is not equal to 5. So we have to consider 3 and 4 because both of them are between those numbers. So what is the value of p of 3? It is 0.7, while for p of 4 it will become 0.11. Then we when we add, it will become 0.18. Okay, so do not forget to subscribe my YouTube channel and hit the notification bell. And happy learning, and I hope that you will learn from my lessons, and you can use this video for your quizzes, long tests, and examinations in the future. So stay safe and God bless you. Have a great day, guys.